In this video, we're going to look at the basics of network flow and looking at an application of directed networks to represent real life situations such as traffic flow or electricity flow or flow of water, for example, through a system or a network of pipes. And some of the things that we're going to be looking at, actually, probably the main thing we're going to look at really is the flow capacity of a network. In other words, how much could this network carry from one point to another? Let's have a look at a basic application, which is traffic flow, for example. And what I've done is I've sort of represented a fairly typical example of say, 3 lanes merging into one, maybe due to some road work or some other obstruction. And then at another point on the road further down, the road then opens back up to 3 lanes in the same direction, indicated by the arrows. Now, where the traffic emanates from, or the start, we call it the source, and we label that with usually with a capital letter S. And where the traffic ends up, or sort of the destination, we call that the sink, and it's normally labeled with a capital letter T. We label the weight of each of the edges as well with the number, or we designate the weight of each edge, which is actually the capacity of each edge with the number. So for example, in this situation, the number 1, actually that's a number 1 here as well, the number 1s represent 1 car at a time, basically. So we've got 3 lanes, and each of these lanes can carry 1 car each, and it's going to merge into vertex A. This is called the inflow. Okay, so the inflow at A, okay, is in fact equal to 3. Okay, because each of these edges represents 1 car each. Add them together, we're getting 3 cars merging into one at vertex A. The outflow of A, however, is equal to 1. So in fact, the maximum outflow of the vertex A has to be the lower of these 2 numbers. So outflow, the flow capacity, or the outflow of the vertex is in fact going to be 1. Okay, there's obviously an obstruction, so 3 cars cannot just merge in together at A. One will have to wait behind the other, obviously, to avoid an accident. Likewise, the total flow capacity, okay, of this entire network would be 1, because it's limited by this edge AB here. Okay, so the flow capacity, which when we talk about flow capacity, it's the entire network. We can see here from this very simple example that it's going to be 1 car.